Welcome. So in this video, what I want to do is cover some topics, some algebraic and arithmetic operations to help prepare you for pre-calculus. So you can see here on this document, we are going to cover combining fractions, add, subtract, multiply, divide, simplifying radicals, combining expressions, as well as factoring expressions. So these are all topics that entering the pre-calculus curriculum you should feel fairly comfortable with. But obviously we know that some of these things we forget, so we want to make sure we kind of cover it. So one of the things that comes up a lot is fractions in the pre-calculus curriculum, and you should have a basic understanding of knowing just how to combine them. So when we're looking at adding and subtracting fractions, remember we have to have common denominators, and you can see here in this case we have a 3 and a 4, so they're not the same denominator. So what we need to do is find a common denominator, and basically what we're doing is we're looking for, well, what number does 3 and 4 both divide into that would be common? And the smallest number, we don't want to just pick any number, the smallest number that 3 and 4 both divide into is 12. And we call that the least common multiple, or you can call it the least common denominator. For this case, I'll just call it the least common denominator. Now, since 3 and 4 both divide into 12, that means if we can get the denominators to be 12, then we can apply our operations. So what do I need to multiply by 3 to get it to be 12? Well, that means I need to multiply it by 4. Now, we got to be careful when we multiply a fraction by, the denominator by 4. We just can't multiply the denominator by 4 and say we're done, because we have to produce equivalent fractions. So therefore, I need to multiply the numerator by 4 as well. Now, over here, we already have a 4, so I'm thinking, again, I need to get that to be 12, so therefore, I'm going to multiply that by 3, and then you multiply that on the top and bottom. So now I have 3 times 1, which is 3, 3 times 4, which is 12, and then plus 1 times 4, which is 4, and 3 times 4 is 12. So now you can look at this fraction and say, oh, okay, so now my denominators are exactly the same. Now I can just apply the operation addition or subtraction, to the numerators, and 3 plus 4 is just going to be 7. So my simplified fraction, or my fraction, is going to be 7/12. And then we always want to look, can we further simplify this? In this case, 7 and 12 do not have any common factors, so therefore we are good to go. All right, moving on to the next example. And this one kind of gets a lot of students too, because they remember fraction operations, but then once we throw in, maybe a whole number or like an integer, they kind of get confused. And just remember, all we need to do to work with integers and fractions is just make the integer a fraction. So all we need to do in that case is just make that a 1. Just put -4 over 1, because -4 over 1 is still -4. And then we look at our common denominator, and say, well, what numbers 3 and 1 have in common, or at least that they both divide into, the smallest of those, and that's going to be 3. So I'm going to say the LCD is equal to 3. Now notice here I already have a 3, so I don't need to do anything over there. But over here, I'll want to multiply by 3 on the top and the bottom. And therefore, I'm just going to rewrite this fraction, 2/3 minus 12/3. Okay, again, we have our common denominators. That's good. And then we're doing 2 minus 12. So it's like you have $2, you owe somebody $12. Now you're going to owe them 10 over 3. Okay, so -10/3. All right, next one, fractions. Love fractions, right? Dividing of fractions. So we have 3 fractions here. You have a fraction in the numerator, fraction in the denominator, and then we are separating the 2 fractions, right? So we have one big fraction. Now, the main case here is when we're dividing by fractions, some people just remember, oh, flip and multiply, which, yeah, it's correct, but I always want to make sure students understand why, because it comes up quite a bit in pre-calculus, and it's not always as straightforward as we want it to be. So the main idea is we have too many fractions going on. So why don't we get rid of this fraction? I don't really mean get rid of it. Why don't we just make this fraction 1? And hopefully you understand that to make a number 1, you just need to multiply it by its reciprocal. So the reciprocal of 3 over 4 is 4/3. Right? Now again, like what we talked about before, if you're going to multiply the denominator by a number, we have to multiply the numerator by that number. And here you can see that's why we flip and reciprocate. Well, 3/4 times 4/3 is just going to go to 1. And then over here in the numerator, now again, remember multiplication of fractions, you're multiplying straight across, which I guess I probably could have done that example next, but whatever. So 2 times 4 is 8. And then 5 times 3 is 15. And then here we have, you can see that this becomes 12 over 12, which is really just 1. And the nice thing about getting this denominator to be 1 is you can see that, well, we don't really need to write that 1 right there, right? I mean, why write 8/15 over 1? So we can just eliminate that and just keep our numerator as our final result. All right, and then the last one is going to be looking at, multiplication here. So I have 2/5 times 9/2. And remember, multiplication is you're just multiplying straight across. Numerator times numerator, denominator times denominator. There's no LCD required, and a lot of students kind of prefer this. Like, oh, it's kind of easy. Just remember, we always want to look into like ways to simplify. And since my fractions here are separated by multiplication, I can divide this 2 over 2 out. So again, let's multiply this out. So you could do 18 over 10. Right? But remember, when you are looking at something like that, you got to find common factors. And you can see that out of 18 and 10, they both can be divided by 2 because they have a common factor. So if I divide out of 2, I'm going to be left with 9/5. I'll kind of put that in a box. Or another way that we can simply do this is say, well, 2 and 2 divide out. They both are giving me basically a 1. And therefore, I could just quickly write my answer as 9/5. So just remember, when you're looking at fractions, always look to like simplify first before applying your operation. But if you forget and whatever else, that's a really bad 9, then you can apply the operation and then simplify afterwards. It doesn't really matter either way. All right, so let's get on to simplifying radicals. So we got an easy one, square root of 16, probably very familiar with this one. But again, when we're looking at the square root, we're saying what number multiplied by itself is going to equal 16. And there's a couple of just important ways to look at this that I kind of want to talk about. So the answer is 4, right? Because we should know our squared numbers, but a couple different ways we could write this and ways to think about this. Really, you see it's 4 multiplied by itself gives us 16, right? And another way you could look at this is 4 squared. And this will become just important in some of my other topics or videos that we'll be talking about. And I just want you to understand that the square root and the squaring are inverse operations of each other. So the square root of something squared, again, is just going to equal 4. And 4 squared is equal to 16, right? So it's just kind of important for you to understand that concept for moving on for later topics. Now, the next one is the square root of 8. And for this one, we just want to kind of remember our properties of radicals. And just remember that the square root of, a times b is equal to the square root of a times the square root of b. Okay? And the reason why I like to do that, because you could use prime factorization, but that's kind of going a little bit farther too back. What I want to do is I want to break up the square root of 8 into a square number. Now, if you forgot your square numbers, let's just go ahead and write those square numbers down, or at least just a couple of them. So remember, square numbers are numbers you can take the square root of. So numbers you could take the square root of is 1, 4, 9, 16, 25, and you can kind of go on and on and on, right? So when you're simplifying a radical, I want to see, can I rewrite 8 as a product with one of these square numbers? And you could say, yeah, you could do 2, right? So I could break this up into 4 times 2. Now, I could further break this down as a product. I could break this up into the square root of 4 times the square root of 2. Now you can see that the square root of 4 is 2, and then we have square root of 2. And then voila, you're done. Okay, so the next one is we have 3 times the square root of 20. Now, we got to be careful with this. Do not take numbers outside of a radical and multiply them inside of a radical. If we have two numbers under a radical and they have the same index, meaning they're both square roots or cube roots, then yeah, you can multiply them under that radicand or that radical. But in this case, this is not under a square root, so we have to leave that on the outside. So we're just going to be very careful with that 3. I'm going to kind of like put it in parentheses because it's being multiplied by the square root of 20. So let's just focus on simplifying the square root of 20, and then we'll come back to using that 3. Now, when we're going through the square root of 20, again, kind of going back to those square numbers idea, we want to pick numbers that we could break down that are square numbers, not just any two numbers. We don't want to pick like square root of 10 times 2. Well, yes, 10 times 2 does give you 20, but we can't simplify the square root of 10, nor can we simplify the square root of 2. So that's not going to be the best numbers to pick. So again, we want to think, what square numbers can we use that are going to multiply by 20? And that obviously would be 3 and 4. So I'm just going to continue the 3 there, and I can break this up into 4 times 5. Okay. Now, the square root of 4 is obviously 2. I could break it down again if I wanted to, but in this case, I'm just going to leave it out there. So I have 3 remains. The square root of 4 is 2. I can't simplify the square root of 5 anymore, so I'm just going to leave that as a radical there. And then we have 3 times 2, which is 6. Okay. All right, now moving on to the next example, I was kind of debating if I wanted to get into the complex number system. Obviously, if that's something that you haven't covered, then don't really too much worry about it. But it is something that typically students going into pre-calculus, into Algebra 2, will be semi-familiar with. So I just wanted to kind of throw in a couple examples to just remind you, because obviously you can't, under the real number system, you can't take the square root or the even root of a negative number. But something we learn in Algebra 2, as well as what we cover in pre-calculus, is using the complex number system. So if you haven't covered that at all, don't worry, but just make that positive and you can simplify it. But for those of you that are a little bit familiar with I and complex numbers, we'll kind of simplify this using the complex number system. So the main idea is just to remember when we have this square root or even root of any negative number, we want to use our imaginary unit, I. And remember, I, the imaginary unit, can basically be represented as the square root of negative 1. All right. So what we're going to want to do here is I still want to break this up just like I've done the other ones, but I want to get that negative to represent as a negative 1, because really, you could represent this as negative 1 times 32, right? And then that would be square root of negative 1. So I'm going to break this up into negative 1 times, now again, we want to go back to our numbers here and say, all right, which square numbers work? Well, again, we're looking at 32. You could say 4 goes in there and 36 goes in there. So the problem with using 4, if you were to do it that way, is you would have 4 and 8. That's a multiplication symbol, right? So you could break this up into negative 1 times, 4 times 8. But the problem is when you go ahead and simplify this, you realize that 8 needs to be simplified, further simplified again. So you'd have to do the process over and over. And there's nothing wrong with that. If that's what you come up with, then awesome, work with it. But usually the idea is to find the largest square number that divides. And in this case, the largest square number that divides a negative 3 root 2 is 16. So what we're going to do here is, I don't like that dot, so I'm going to change that. So I'm going to multiply this by 16. Oops. 16. And then that's going to be multiplied by 2. Okay, now again, we could break this up. And for this case, I guess, I will just break them up. So we have the square root of negative 1 times the square root of 16 times the square root of 2. All right, now the square root of negative 1, as we mentioned, is representing our imaginary unit, I. The square root of 16 is represented by 4. And then we can't really do anything with the square root of 2, so we're just going to leave that as the square root of 2. Now, that is perfectly fine. That's not really in our preferred way to write the answer. Usually, we kind of treat I as kind of, since I is not technically a real number, we're going to kind of treat it as like a variable in the sense that we prefer to write this like 4I times the square root of 2. And again, it's still multiplication. It doesn't really matter 2 times 3 or 3 times 2. Just write in that way. You could write the I at the end, but I just want you to be careful that if you write the I at the end, a lot of times people will have the I under the square root, and that's incorrect. And if I was grading your test or, if you saw something like that, that could be a problem. So the best thing to do, or at least what I do when I'm writing like on the board, is I go ahead, if for whatever reason I do this, which I guess sometimes, it happens, I'll have the square root of 2, and I'll just kind of end the square root there. So therefore I know that the square root stops, and then I'll add the I at the end. Okay, and sometimes there will be cases where, it might make sense to have it rewritten like that, or in this case. All right, so let's move on to our last one, our combining expressions. So I had to pick a nice easy problem, right? I mean, geez. It makes me feel good to kind of go back and like, hey, I remember this, 3x plus 7x. And the way I remember when, like in Algebra 1, remember x's are unknowns, right? But we have 3 of x's and we have 7 of x's and we need to add them. So, that means we're going to have 10 of them. And, even though apples are not unknown, it's like 3 apples plus 7 apples equals 10 apples. Well, now we're just dealing with x's, which are unknowns. But this one's fairly simple. Just remember when you're combining, adding, and subtracting, you combined the coefficients and then leave the variable as it is. So in this case, we're just going to have 10x. Actually, let's use a different color. Let's go back to red. So in this case, we'll have 10x. All right, so now in the next example, now we have some subtraction. And there's a couple different ways we could do this. We could rewrite this in the vertical method. We could do this horizontally. I prefer just to rewrite subtraction as addition problems because, I make mistakes. I can get careless. I'll be talking, think about something else, and I'll usually make a mistake dealing with a negative symbol or subtraction. So whenever I see subtraction, I prefer to rewrite it as an addition. And, it's very simple to rewrite an equation as subtraction. Like 1 minus 4 is the same thing as 1, as 1 plus negative 4, right? So all we need to do is just change this to an addition and then distribute this negative. So the first thing I want to do is distribute the negative to both of my terms, right? You got to apply the distributive property, and then I can change this to an addition. So when I rewrite this, I have 1 minus 3x plus, you can think of this as like a negative 1. Negative 1 times negative 3 is now a positive 3, and a negative 1 times 4x is now a negative 4x. Now, you could combine these just as it is, or you could rewrite this and, rewrite them. Just make sure you're keeping the signs where they're at, or, if they're positive or negative. But you can rewrite them so they're like grouped together. So I could say, 1 plus 3 minus 3x minus 4x. And that way, by grouping, it's a little bit easier for me to apply the operation. 1 plus 3 is 4. Negative 3x minus 4x is going to be a negative 7x. Okay? Working on the next one, we have multiplication. Multiplication of two binomials. Just remember the distributive property applies, right? We have to make sure we multiply every single term times every single term. You could use FOIL. You could use the box method. Whatever you have previously learned that you remember, just remember you got to have every single term accounted for as multiplying by the other term. So a lot of times, once we get into pre-calculus, I start doing these rather quickly and I don't show my work. So it's important for students just to remember, I'm multiplying everything by everything. So I have x times x, which is x squared. I have x times 1, which is 1x, which I can just write as x. I have negative 3 times x, which is a negative 3x. And I have negative 3 times 1, which is going to be a negative 3. Then my middle two terms combine. So I have x minus 3x, which is now going to be negative 2x. So I have x squared minus 2x minus 3. Okay? And therefore, you get our famous trinomial, which we'll come into next. All right, so the next one, you could look at this one and say, oh, it's the same operation. And it is. And you could go through this, again, the exact same way that I did the last example. However, typically, a lot of times, it's a little bit easier to rewrite the expressions. And especially when we have negatives, a lot of times, it's really easy to kind of get rid of these. Now, or to rewrite them to kind of make our operations a little bit easier to understand. So this negative here, I'm going to think about this as a negative 1, okay? And then we usually like to write our x's in front. So therefore, if I rewrite this, I can rewrite this as negative x plus 4 times x plus 4. Okay, now you look at this and say, well, all right, now it's, I can apply the negative here, and, then you could go ahead and distribute, and that's perfectly fine. You could also factor out a negative. So you could either, factor out a negative, or you could distribute this negative across. Either way, what you're going to get is you're going to get a positive x minus 4 times a x plus 4. Now, this brings up the difference of two squares, which is extremely important. Shows up all the time. I am going to work this one out because I'll do it the one time. Otherwise, I just use the understanding of, hey, this is the difference of two squares. I already know what the expanded form is going to be. But let's just go in again and prove this. Again, notice that the first two terms are exactly the same, x and x's, and the last two terms are exactly the same, but we have alternating signs. So x times x is going to be x squared. X times 4, actually, x times 4 is going to be a 4x. Negative 4 times x is a negative 4x. And negative 4 times 4 is going to be a negative 16. So what you see here is that the middle terms add to 0. 4x minus 4x is going to be 0x, which is just 0. So therefore, we're left with our final product of x squared minus 16. So again, whenever you see that special case, you can simply just, follow the kind of pattern and to your difference two squares. It just saves a lot of time. Health up. All right. The arch nemesis of so many students for pre-calculus is factoring expressions. Now, when we get into my class, I do a lot of practice with factoring. So I'm not going to get into the, Algebra 1 and Algebra 2 methods and breaking it down because factoring comes up a lot, especially in pre-calculus and calculus. And we have to be able to know how to do it, rather quickly and not have to show a lot of work on how to factor an expression. So the way that I'm going to teach factoring, at least in this class, is, rather kind of like a quick method. However, I do understand that a lot of students really, really struggle with factoring. So I do have a lot of worksheets and practice and slower instruction for them that need the help. But however, for other students, or at least for students, the majority of students coming to pre-calculus, I'm going to kind of move through this rather quickly, or at least not break down the steps, because that is something I cover in, as kind of like an appendix to the class. All right, so the main idea that I want you to come with factoring is notice that when we have the product of two binomials, the middle terms combine and we get a trinomial. So basically the process of factoring is rewriting an expression like this as a product of two factors. So you can see here, when I multiply, I get a trinomial. And basically factoring is like the reverse process here. So what we're looking into doing is we're looking to take an expression like this that's separated by subtraction or addition and rewrite it as a product. And that becomes very important in the class. So if we're going to break this up, we know that if we're going to break this up, we can see that this is a trinomial. So we're going to want to write this as a product of two binomials. Now, the first two terms is we know we're going to multiply. We're going to want to get x squared. And the greatest thing about factoring, which a lot of students still don't do, is remember you can always check your answer by simply multiplying, right? So we have x times x is x squared. Now, kind of one of the tips you're thinking of in factoring that a lot of times we talk about is, what two numbers multiply to give you 2, but then add to give you -3. So you want to think about all the factors of 2. And fortunately, 2 is rather simple. It's 2 and 1. But they don't add. 2 and 1 gives you 3, not -3. So then you think, oh, well, what about -2 and -1? Because -2 times -1 gives you 2, and -2 plus -1 gives you -3. So therefore, we can just put a -2 there and a -1. It doesn't really matter because, again, by distributive property, everything's going to be multiplied by each other. So we're good to go. And again, if we wanted to check our work, x times x is x squared. X times -1 is -x. -2 times x is a -2x. And -2 times 1 is 2. And you can see that once we combine our middle terms, we're good. Now, the next one, this looks like a difference of two squares, and you could factor it by as far as difference of two squares, just like we did over here. I always like to, again, think about, rewriting these and, just so you can kind of get the idea of visualizing a revision of this problem. So if I rewrote this as a -x squared plus 1, what I see is I could factor out a negative. And by factoring out a negative, I now obtain x squared minus 1. Right? Now, again, you could still factor this out and then factor out a negative later. But now you see that, oh, this is like an x squared minus 16. So the product is going to be whatever the square root of this number is, plus or minus. So we look over here and we say, well, the square root of 1 is just going to be 1, and then it's plus or minus. So we have a negative x minus 1 times x plus 1. Good to go. All right, next one. One of the very, very important things to remember about factoring is when you're factoring, always look for common factors, right? Just like when we went to factor or with, radicals, or when we talked about fractions, always want to simplify. So in this case, you can see that I want to simplify out. I want to simplify out. I want to factor out any common terms. And you can see from 2x squared minus 12x plus 18, they all share a common factor of 2. So I'm going to factor out a 2. And by factoring out a 2, it's just like dividing out a 2. You're basically dividing every term by 2. So therefore, I get x squared minus 6x plus 9. Okay? And then we kind of go back to that general question, like what two numbers multiply to give you 9, but then add to give you -3. And you say, all right, well, 9, there's only 9 in 1 and 3 in 3. But again, they can't add to give me 3 and 3 don't give me a -6, they give me a +6. So therefore, I need to change the factors to -3 because -3 times -3 is +9, and -3 plus -3 is -6. So it works out. Now, there's another kind of special case, which we call a perfect square or binomial squared. This is a perfect square trinomial, and that produces a binomial squared. Well, this isn't squared, but you see that the two factors are exactly the same. So a simplified version that we could write this as 2 times x minus 3 squared. Okay. All right. Last but not least, when a is not equal to 1, and you cannot factor it out. So in this case, we can't factor out a 2, right? So we're kind of stuck in that regard. So what we need to do is, again, at least we have our understanding that this is a trinomial. It's going to be 2 binomials. And that's basically my understanding that I'm going to want to work with on this one. So I'm going to break this up into 2 binomials. All right, and there's a lot of great techniques if you really, really struggle with this, but I'm just going to kind of go through a simple one. Now, notice when I'm multiplying my 2 binomials like I did over here, the first 2 terms give me that x squared. So I kind of want to think, well, what could I have to give me 2x squared? Well, I could have a 2x and an x, right? Now, I need to have 2 numbers that give me 3. Well, I kept this pretty simple. You either have 3 or 1 or -3 and -1. But so you could just play around with it. Like you could put a 3 here. Like if you put a 3 here, +3, and a +1 here, that's fine. 2x times x gives you 2x squared. 1 times 3 gives you 3. But it fails when we start to find our middle terms because 1 times x is x, and then 2x times 3 gives us 6x. So that adds up to give us 7x. So that's not going to work. However, what I kind of notice is if I swap those numbers around actually, and I make this a 3 and this a 1, now I think it works out. 2x times x is 2x squared. 3 times 1 is 3. And then let's multiply let's just write out. So 2x, that's 2x squared. 3 times x is 3x. 2x times 1 is 2x. And then 3 times 1 is 3. Right? And so you can always check your work, again, by checking your stuff. And so therefore, we have 2x squared plus 5x plus 3. Okay, so that is now our factored. That is now going to be our factored form. And again, there's a lot of longer techniques that we could go through, but that's just a rough example because it comes up, but not all the way. So there you go, ladies and gentlemen. That is our first installment for preparing for pre-calculus. Hope you enjoyed. Thanks.